Hello everyone, welcome again to our physics solving session, and today we meet the topic, the eighth topic, and it is called temperature. Okay, so the first question for today is define temperature, thermometer, and fundamental interval of a thermometer. We are required to define these three terms. These are very commonly used terms, asked terms in the exam, so it's very important that we remember it by understanding. So, definition of temperature is the degree of hotness or coldness of a substance. When I say temperature, I mean the degree, the amount of hotness, the feeling of hotness or coldness of a substance. So it can be either hot or cold. It's not necessary that the body is hot for it to have a temperature. It can also be cold. Actually, temperature can actually be expressed up to in negative numbers to represent coldness, and mostly positive represent hotness. So if I say maybe the temperature of this substance is negative 50, I mean that body is actually let's say negative 50 degrees Celsius, I mean that body is actually very cold. But if I say, let's say it's 50, I mean it is hot. Thermometer is a device used to measure temperature. So how can you measure the temperature? How can you measure the degree of hotness or coldness of a substance? By using a device that is known as thermometer. So thermometer is a device that is used to measure temperature. Fundamental interval of a thermometer is the span of numbers between its two fixed points. Usually, a thermometer has fixed points. Let's assume this is the thermometer. It has two fixed points with numbers in between. Two fixed points with numbers in between. So these numbers between the two fixed points is known as the fundamental interval of a thermometer. These are my two fixed points. Let's say one is 0 and one is 100 degrees Celsius. 100 degrees centigrade, not Celsius. Fundamental interval of thermometer is the span of numbers between its two fixed points. Okay, the second question is matching items. We have to match the items from list A with that of list B by choosing the most correct answer. Okay, so I have mercury, alcohol, 0 degrees, steam point, maximum and minimum thermometer. And from list B, I have it freezes at 115 centigrade, it boils at 360 centigrade, 273 Kelvin, is a good conductor of heat, and I have 100 degrees centigrade. Remember, if you want to choose the most correct answer, you have to first look at all the options given. Do not go in a haste. You have to be careful when choosing, because sometimes there may be more than two answers that are alike, so you have to be very careful. Okay, so the first option here is mercury, and I can see from these options the most correct option is going to be 2. It boils at 360 centigrade. This is a fact, so I'm going to write here 2. And then I have B, alcohol. It freezes at 115 degrees centigrade. Therefore, you may see an alcohol and it's written as negative 115 centigrade. It means that this alcohol freezes. Its temperature is 115 centigrade. And then I write here 1. And then I have the third option, 0 degrees. Since I have already chosen 1 and 2, I cannot choose them again. So I am left with 3 options. 0 degrees. The most likely answer here is going to be 3. 273 Kelvin. So I write here 3. Because if a body is if the body has temperature of 0 degrees, it means in Kelvin scale, in Kelvin, that body has temperature of 273 Kelvin. This is in degrees centigrade, so here in Kelvin it is 273. So the most likely answer here is going to be 3. And D, I have steam point. Steam point, we know that it is the point where something boils, which is 100 centigrade. So I highlight to show that I have already chosen this option. I cannot choose it again, and then I write 5 for steam point. Temperature at which something boils, liquid boils. And then I have maximum and minimum thermometer. This is actually one of the type of thermometer. There are different types of thermometer, and one of the type is known as maximum and minimum thermometer. It is a good conductor of heat? Of course. Since thermometer is used to measure temperature, it should be able to conduct heat. Therefore, maximum and minimum thermometer is a good conductor of heat. Therefore, I write here 4 to represent its answer. Remember, we have finished the number 2 question of matching items, but remember, you should be very careful because here it was kind of easy, but you might find some options whereby you have to be very careful because there are more than 2 answers which are alike. Okay, the third question says, why mercury is more preferred to be used as a thermometric property compared to alcohol? Why mercury is more preferred to be used as a thermometric property compared to alcohol? Mercury, alcohol. Why mercury is more preferred to be used as a thermometric property compared to alcohol? And the answer is because here the question wants us to give reasons to why mercury is used instead of alcohol. What makes it to be the first choice instead of using alcohol? This is because mercury, it does not wet glass, but alcohol, it wets glass. If you take glass and you put mercury in it, you are not going to find the droplets because mercury does not wet glass. But if you put alcohol, then your glass is going to be wet. Similarly, for thermometer, that's why we use mercury, because it would not wet the glass. And then mercury, it boils at 360 degrees, but alcohol, it boils at 78 centigrade. Mercury boils at 360 degrees, but mercury, it boils at 78 centigrade. This means if I want to measure temperature, here we can see that the range of temperature for this alcohol is very small, such that the liquid is going to boil at a very low temperature. But if I were to use mercury, then I have a very varied range of temperature from which the liquid is going to boil. Therefore, it is more preferred to use mercury. Okay, and the fourth answer is it is opaque. Therefore, it can be clearly seen. Mercury is opaque, therefore it can be clearly seen. But if I use alcohol, then it is colorless. I have to use color when I use it. Therefore, it is more optional to use mercury than alcohol. Also, mercury expands steadily. Its expansion is steadily, but if you were to use alcohol, its expansion is abrupt and rapid. Therefore, due to these factors, it is more preferred to use mercury as a thermometric property in your thermometer. It means compared to alcohol, because it does not wet glass, because it boils at 360 degrees, it has wider range of temperature compared to alcohol, because it is opaque, therefore it can be clearly seen, and because it expands steadily. Okay. The fourth question says the temperature of a liquid is nitrogen is 77 Kelvin. What is the temperature in Celsius scale and Fahrenheit scale? The temperature of a liquid nitrogen is 77 Kelvin. What is the temperature in Celsius scale and in Fahrenheit scale? Okay. So first I have to write it in Celsius scale, and then I have to write it in Fahrenheit. From the formula I know that if I have a temperature in centigrade, let's say centigrade here, it is equal to temperature in Kelvin minus 273. So from this question, I have the temperature in Kelvin as 77 K for temperature in Kelvin. So if I want it in Celsius scale, I have the temperature in Celsius centigrade is going to be 77 minus 273, which is given by negative 196 degrees centigrade, and this is the temperature in Celsius scale. See, there's negative here. It means that this temperature is actually decreasing. So the negative should not confuse you. But remember, if something is in Kelvin, it cannot have a negative. But if it is in centigrade, then it can have negative. Also, in Fahrenheit, we know that if we want to write something, if we want to write our temperature in Fahrenheit, it is given by 9/5 degrees centigrade times, it is 9/5 degrees centigrade plus 32. This is how you can change if something is in centigrade and you want to change it in Fahrenheit. So I have Fahrenheit here is equal to 9/5. The temperature in centigrade is given by negative 196. I have found it from here, plus 32. I get negative 320.8 degrees Fahrenheit. So I have answered the question. I was required to change it to express it in Fahrenheit scale, and it would be given as negative 320.8 degrees Fahrenheit. Okay. Let's look at question 4b. That was 4a, and now let's look at question 4b. It says, object A and B are identical in every way except for their temperatures. It means they are the same in every single aspect except for their temperatures. Their temperatures are different. The temperature of A is 10 degrees centigrade, and that of B is 50 degrees centigrade. If the two objects are placed in contact to each other, they will come to thermal equilibrium. What will be their common final temperature and why? So I have object A and I have object B. Object A has temperature of 10 degrees centigrade. Object B has temperature of 50 degrees centigrade. And then I bring these two objects in contact. They reach thermal equilibrium. What will now be their final temperature and why? Okay. So, final temperature final temperature, let's write it as F. Final temperature F will be, I have to take 10 plus 50 divide by 2, which is going to be 60 divided by 2, which is equal to 30 degrees centigrade. Therefore, the common final temperature is going to be 30 degrees centigrade. It means body A would now have 30 degrees centigrade and body B would now have 30 degrees centigrade. This question, it's written here, what will be their common? It means now all the two bodies will have the same final temperature. So and that temperature is 30 degrees centigrade. What will be their common final temperature and why? They have the same final temperature because they have now reached thermal equilibrium. It means heat has been transferred in such a way that all bodies now possess the same kind of energy, heat energy. From the 50 centigrade body, some of the heat has been transferred to body A, and now they have reached a state whereby they all have the same temperature. That is they have reached thermal equilibrium. Okay, and the last question for today, it says, what are the limitations of a clinical thermometer? We know there are different types of thermometer, and one of the type is known as a clinical thermometer. What are the limitations of using this type of thermometer? And the answer is, they do not necessarily reflect the core temperature of the body. Let's say the temperature of the body is actually 52. But with clinical thermometer, they do not necessarily show 52. They might show something which is approximately to 52, but it's not the core temperature. They might or they might not. So it's not necessarily that they show the same temperature as that of the body. So that's the first limitation. The second one, they may spread infections if not properly sterilized. If you are using the clinical thermometer on, let's say, on a patient, and then you use the same thermometer on another patient, if you have not properly sterilized it, then it may spread infection from the first patient to the other, or from the first person to the other. Also, the third limitation is they are delicate and can break easily. If you touch it by using force, then it's going to break very easily. Therefore, they are very delicate, and we do not want, it is not more preferable to use devices which are very delicate, because accidents happen. So the limitation is that they are delicate and can break easily. Okay, let's look at the last question for today's session, and it says, write down 4 precautions to be taken when using a clinical thermometer. You are using your clinical thermometer. What are the 4 precautions that should be taken? And the answer is, do not bend or bite the thermometer. Do not bend or bite the thermometer. Keep the thermometer away from the children, because if you keep it in a place whereby children can reach it, they can be able to bend it or to bite it or even to break it. So keep the thermometer away from children. Sterilize after use to avoid contamination. Clinical thermometer are used in clinics. Therefore, they can be used from one patient to another for different patients, but they should be properly sterilized. If you're not sterilized, you can contaminate germs, you can cause contamination. Therefore, the precaution that you should take is you should sterilize after use to avoid contamination. And the 4th precaution you should take, do not use a damaged or broken thermometer, as it can cause injury. If you have seen that the thermometer is broken, do not use it, as it can cause injury. Those are the 4. There are actually a lot of precautions, but the question here wanted us to write only 4. With that comes the end of today's session, temperature. I hope you thoroughly enjoyed, and be sure to solve more questions to be able to fully master this topic. Until then, goodbye.